Well, hello, my dear. This is Ujjwal Kumar saying, and today I'm back with another topic. In this topic, I'm going to share with you what you need to know to solve question in radiation when heat exchange between two non-black bodies is taking place. Well, in this topic, in the gate examination, they have already asked you the same question, which is I'm going to share with you. So, in this video, you are going to learn about its basic concept as well as the question which has been asked in gate. If I am not wrong, this question has been asked in gate 1993. Okay, so don't worry, I will share with you how to solve that question right away, and of course the basic concept behind this topic. So basically, what is this? Heat exchange between non-black bodies. Suppose that we are having two bodies, body 1 and body 2. Every body is having different properties, just like emissivity of the body, ms epsilon 2, temperature of the body, as well as here in case of radiation, one law play most important role, that is Stefan Boltzmann law. Stefan Boltzmann law. According to this law, according to this law, you must say Q is directly proportional to T to the power 4. That's why Q is equal to sigma A and T to the power 4. This is the right way, this is the main formula of this law. But after then we have many things to do with this formula. But yes, this is the most basic formula, I must say that. And sigma is known as Stefan Boltzmann constant. So this is known as constant, and you know constant term having some constant value, just like universal gas constant, and here in Stefan Boltzmann constant having a constant value, that is 5.67 into 10 to the power 8 minus 8 watt per meter square K to the power 4. So this is the constant term and its value is 5.67 into 10 to the power minus 8 watt per meter square K to the power 4. Sorry for repeating, but yes, I'm repeating because this is important. Yes, my dear, this is really important for you. Now, what is the basic formula we require to find out heat exchange between two non-black bodies? But body must be parallel to each other, just like we have shown here in this pretty diagram. Suppose that we are having two bodies, body 1 and body 2, and these two bodies are parallel to each other. That's why this formula, which formula just I am going to share with you, will be applicable. Okay, so what's that formula is about? Suppose that this is body 1, this is body 2. If I wanted to find out heat is exchanging from body 1 to body 2, then what would be the formula for that? So that is Q1 to 2 is equal to sigma A T1 to the power 4 minus T2 to the power 4 by 1 by epsilon 1, 1 by epsilon 2 minus 1. So this is the formula for finding out heat transfer rate from body 1 to body 2 if both the bodies are in the parallel planes, I must say, not having. Okay, so this is the formula for finding out all those equations. And here epsilon 1 and epsilon 2, epsilon 1 is, as I have already shared with you, epsilon 1 is emissivity of the body 1 and epsilon 2 is emissivity of the body 2. I hope you are getting me right. So this is the formula for finding out heat transfer rate. Now let's go for that question, which question has been asked in GATE 1993. So that's why if you're preparing for GATE, then definitely you can solve this question. Well, I have seen in the some university examination, they have also touched this topic. So if you are preparing for any university examination, then even you can study this topic. This topic is really going to help you to grab basic concept of it. Okay, I hope you are getting my point right. So let's go for that numerical problem. I am sure you are interested to learn that numerical problem because that is most amazing part of this video. Okay, so let's go for it. Yeah, Now the question is in front of you. I hope right now you can see the question, right? So if you are seeing the question, then you can read it, and if you are preparing for GATE, then you definitely probably you have gone through this question. So in this question, what we have given, let me read first. The radiative heat transfer rate per unit area between two plane parallel gray surfaces. So suppose that we are having two surfaces, surface 1 and surface 2, and both the surfaces are gray surfaces. That's why, as you can see, epsilon is same for both the surfaces. So here you can see, you can say epsilon 1 is equal to epsilon 2 is equal to epsilon. That means emissivity is same for both the surfaces. Okay, now what I have to find out? Heat transfer rate per unit area. That means QYA I have to find out. So if we'll see its unit, then what per meter square, as already they have shared with us in the question. So if you know this formula, which formula I have just shared with you, then definitely you can make this formula as they have S in the question. So you have to just send this A to this side. So Q by A sigma T1 to the power 4 T2 to the power 4 1 by epsilon 1 1 by epsilon 2 minus 1. So this formula will be helpful for finding out the value heat transfer rate per unit area for the question. Okay, so remember this formula. Okay, I'm going to that question only. That's why I can solve that question in front of you within the it's a matter of few minutes, as I am sharing with you right now, because I wanted to make you understand each and everything. That's why it is little bit taking time. But once you will practice all these problems, and definitely you can solve the question within a minute. It's a game of minutes only, nothing else. Okay, so let's go for the problem. Now what we have given in the question, sigma, we have to find out Q by A, and we have a formula sigma T1 to the power 4 T2 to the power 4 1 by epsilon 1 1 by epsilon 2 minus 1. Now what we have to do, we have to just put formulas, we have to put values in the formula we have given and the question also. So we have given Stefan Boltzmann constant sigma is equal to 5.67 into 10 to the power minus 8. So let's write this 5.67 into 10 to the power minus 8. Now T1 temperature is 400, T1 and T2 temperature is 300. So 400 to the power 4 minus 300 to the power 4. Now as I have already shared with you, both the emissivity for both the surfaces is same. So 0.9 1 by 0.9 minus 1. Yeah, right now you can see, isn't it? So now what you have to do? Now what next? Tell me. I know what you are thinking right now. We need calculator. So let me just find out where is calculator. Yeah, I got it here only. I have a calculator. I have a calculator right now, and I hope you can see. Okay, just yeah, you can see. So basically what we are going to do, we have to first solve this lower part. So 1 divided 0.9 plus bracket 1 divided 0.9 is equal to how much? This much. Minus 1 is this much. So 1.2222. So in the lower part we are having 1.4 times 2. Now in the upper part what we have, 400 to the power 4 minus 300 to the power 4 is equal to how much? This much, into 5.67 into 10 to the power minus 8 is equal to this much. So how much values we got here? 992.25. 992.25 divided by 1.222 as 4 times 2. So the answer is 81185 watt per meter square. Now we have to go through the option. We have given option, I haven't write, okay, A, B, C, D. Probably we have given option 812, 810, 808, 806. So answer would be, if 12, then answer would be this. A would be the right answer. But I haven't written, so you can see what type of option they have given in the gate examination, right? So what about this topic I have shared with you? This is the topic of heat exchange between non-black bodies. So what you required basically to solve question related to this topic: first, you need to read the question carefully, that what topic they have asked in the question first. Second, you have to find out what you need to find out from the question. And third, you need to remember the formula, which formula is useful for solving the question. If you will go through this step, I mean what steps I am sharing with you, then definitely you can solve the question right away, and definitely you can score better in the examination. I hope you have learned something from the video. Thanks for watching. See you soon in my next video. Bye bye.